Hi, this video will talk about how to evaluate a function and then talk about the domain of a function. So first of all, let's get to evaluating. Here we're using function notation, and what function notation does is allow us to name our function. In this case, I've named it f. All right, and then we say of x, and what this does is allow us to tell you what to evaluate the function as. So for example, over here I wrote f of 2. What this means is I go to my function, all right, and instead of having an x there I have a 2, and what that means is I go to my function, wherever I have an x I'm going to plug in a 2. So to evaluate this function at f of 2, I get 1 over 3 times 2 minus 7. That actually equals 1 over 6 minus 7 equals 1 over negative 1, which equals negative 1. So my answer is f of 2 equals negative 1. All right. And you can see why function notation is actually a little simpler. Before I had to write out evaluate f when x equals 2 and yada yada yada. Now I just simply put in my number. Here I want to evaluate f at negative 3. So I go to my function named f, here it is, and wherever I have an x I'm going to plug in a negative 3. So in this case I would get 1 over 3 times negative 3 minus 7. This gives me 1 over, well, a 3 times a negative 3 is negative 9 minus 7. So I get 1 over negative 16. So that's actually my answer in this case, negative 1/16. Okay? So that's how we evaluate a function. Now let's talk a little bit about domain. When I say domain, you think x values. And what this means is all valid inputs for x, okay? And we really only have two watchouts thus far anyway. When we're dealing with a function such as this one, we cannot have a 0 in the denominator, all right? Otherwise, any other x value is fine. But whenever we have a 0 in the denominator, so for example, if I have 1 over 0, this is actually undefined, okay? All right? So an x value, when plugged in, that gives me a 0 in the denominator is not a valid x value, and therefore it is not in the domain. Okay, so what x value in this case, when plugged in, would give me a 0 in the denominator? Well, I can just look at it and tell that it's going to be 7 over 3. Okay, all right. Why? Because 1 over 3 times 7 over 3 minus 7. My 3's here would cancel. I'd get 7 minus 7. Uh-oh, I got 1 over 0. So sad. Okay, this is undefined. All right. So when I get ready to define my domain, all right, I say all real, okay, such that x is not equal to 7 over 3. Okay, so that would be my domain. All right. If you don't see right away that it's 7 over 3, then just take your denominator and set it equal to 0. Okay. And if we solve this, you would get x equals 7 over 3. Okay. And that would tell you that that cannot be part of the domain. All right, moving on to our second example. First, we're going to evaluate this function at 2, so that's going to be equal to, I'll go to my function named f, in this case it's square root of 5 minus x. Wherever an x, I'm plugging in 2, so I get 5 minus 2. So the answer to this would be the square root of 3. Now if I'm asked to evaluate it at f equals negative 3, I go to my function named f. Wherever I have an x, I'm going to put in a negative 3. So I get the square root of 5 minus a minus 3. So that's going to give me the square root of 8. All right. Now my first watch out is I cannot have a 0 in the denominator. My second watch out is I cannot have a negative under the radical. All right. Why? We haven't quite gotten there yet. And so when we're talking about real numbers, that's not defined. So no negative under the radical. So I want to look at this and determine what values of x keep a 0 or a positive value under the radical. All right. So in this case, my domain has to be x such that x is greater than, or I'm sorry, less than or equal to 5. Okay. If I plug in 5, I get 0. 0 is okay. If I plug in 4, I get 1. 1 is okay. If I plug in 3, I get 2. That's okay. But if I plug in any value over 5, 6, all right, I'd get the square root of 5 minus 6, or the square root of negative 1, and that would be uh-oh. Okay? All right. So I can't have a negative under my radical. So when we're talking about domains, the first watch out is you don't want a 0 in the denominator, and the second watch out is you don't want a negative under the radical. So you want to pick the x values that make those two things true.